Hi there guys, in this video we're going to have a look at standard deviation. Now, imagine we've got a data set of 4 numbers, all of which are 6. So the mean would be really easy to calculate, it's 6. Now, as a shortcut to write the mean, we often write this, and that's pronounced x bar, okay, because it's got a bar on its head. So x bar is 6. Now, we've also got another set of data here, and you should be able to see pretty happily that the mean is also 6, so I'll write x bar is 6. And again for this one. Okay. Now, what's interesting to do here is actually to try and draw this data. So let's imagine I draw a line, and this line represents the mean, so the mean of 6. Because all of these data values are actually 6, if I was to plot them on a line, well, they would all be on the line. It's not very interesting. It becomes a little bit more interesting when we do this one. So you can see the first point here is actually 2 marks below the mean. So I'm going to just draw this to show that those results are 2 below the mean. And the 8s, they're actually 2 above the mean. So they're up there. So +2 and +2. And if we draw this one, so we've got 3 below the mean, so let's just try and draw that a little bit further to emphasize that. 5 is just 1 below, so let's do that, and the 8s, well, they're the same as before, so let's pop those on there. So when we look at this data, we can say, well, there's no spread here. This data is spread out from the mean, and this one's even more spread out. We've got a much further spread on this one. And it's this spread is what we are interested in measuring. And we would say, well, this is deviating. So the natural word we came up with was standard deviation. And we just wanted to find the average of this spread. Okay, so the first thing mathematicians tried is, well, if we find the average, where do we get these numbers from? Well, that was these scores take away the mean. So we could write that like this. So the scores take away the mean. Just find the sum of all of those and divide by how many we have. Okay, so if we do that, we'd actually have, well, 0 plus 0 plus 0 plus 0 divided by 4, there's 4 pieces of data, well, that would give us 0. We're like, great. You know, we're not expecting any sort of deviation there, so that's perfect. But let's try it for this one. So we've got -2 plus -2 plus 2 plus 2 divided by 4. Oh dear. That gives us 0 as well. And you'll find that this one also gives us 0. So that was no good. So then we said, well, you know, we can't have that. We can clearly see there is a deviation, so we need to find another measure. So what we naturally did then is look at the modulus score, which, if you haven't come across modulus, is, you know, really just, if you look here, the difference is actually 2, irrespective of whether it's above or below. So we're just going to take the positive values. So we say here's the difference is 2, difference is 2, difference is 2, difference is 3, and the difference is 1 there. So we're going to, again, this would be 0 plus 0 plus 0 plus 0 divided by 4, which is 0. This one, we're going to have 2 plus 2 plus 2 plus 2, yeah, just looking at the differences, divide by 4, and yes, that's 2. That's good, we've got a deviation. Let's try it for this one. So we have 3 plus 1 plus 2 plus 2. Okay, well, that's also 2, which that causes us a slight issue because we can see that this one is more spread out. So we were hoping to get a different value here. So this one is also no good. So then what we tried is thinking, well, quite like the idea of them being positive. So if we square these differences, then, you know, that's going to help us. But if we start to square things, obviously we've got to undo that. So we're going to square those differences, you know, find the mean of the squared differences, but then we're going to square root it. So here again, you know, I think you'll forgive me for just writing 0 there. But here we're going to have -2 squared plus -2 squared, they're the first two, plus 2 squared plus 2 squared. Well, and then divide that by 4, and then square root it all. Well, 4 plus 4 plus 4 plus 4, that's 16, divided by 4, okay, that equals 2. And now, this one would be -3 squared plus minus 1 squared plus 2 squared plus 2 squared divided by 4 and square rooted. Okay, 9, 10, 18. So this is actually, that's definitely going to be bigger than 2. In fact, if you use your calculator to 2 decimal places, you will get 2.12. So that made us happy. So this is the formula for standard deviation. Now, I will say this can take quite a lot of time. So we rewrite this formula as this. So we're going to have the sum of x squared over n minus the mean squared. So you can see it's very similar, but this is what we use for ease. So if you look it up in a book, this is the one you're going to use. Now this is all well and good for a list of data, but when we have data in a frequency table, we're going to amend this ever so slightly, but you're going to have to check that out in the next video. Okay? But just to reiterate, you can ignore all of this. I was just taking you on a journey of how it actually came about. But this is the formula, and hopefully that made sense.